Hello guys and welcome. I hope that you're having a good day or good morning or good evening. This is I play 4K, aka I play AK, aka I play 16K, and during this video I'm going to show you Counter-Strike Global Offensive running in 16K resolution, rendered in real time, or 133 megapixels rendered in real time and downscaled to 8K resolution native screen. Okay, on a single GeForce RTX 2080 Ti. This is the world's second video ever uploaded to the YouTube Counter-Strike Go or CSGO or Counter-Strike Global Offensive rendered in 16K resolution, guys. Okay, the world's second video on YouTube, available in June of 2019. I uploaded the world's first Counter-Strike Go at 16K resolution on two RTX 2080 Ti back in May of 2019, and that video will be available in the end of this video or in the video description for you to check it out and compare the performance. So enough talking. On the background, as you can see, this is my system that I'm running today. Exact the picture. It's water cooled on a CPU by H150i Pro Corsair hybrid water cooler. I'm running today 15,360 pixels by 8,640 pixels as my desktop resolution, and this is how we're going to run full screen windowed mode in Counter-Strike Go. Let's go ahead and execute the game. I'm also using today, guys, Core i9 9900K overclock at 5.2 gigahertz per core, or 5200 megahertz per core, but I disabled two cores and I disabled the hyper threading technology just to keep this 5.2 gigahertz stable as rock per each core. 6 cores, 6 threads, 5.2 gigahertz. The higher frequency per core, the more FPS, and today we definitely need as much as FPS as possible, especially during this test on a single RTX 2080 Ti video card. Okay, we just booted up. It's almost crashing us, but it didn't, thanks God. And let me real quick go ahead and show it to you guys. I'm going to show you three different presets. I'm going to show you low, medium, and high, which is the maximum preset. In all of these presets, and three of these presets, anti-aliasing will be off. Let me switch to video settings. Okay, so as you can see over here, the resolution 15,360 pixels by 8,640 pixels, exactly as my desktop resolution. I'm running full screen window, doesn't matter, under the Windows 10 Pro, that's using the DirectX surface as its native. Acceleration, render API, everything will be set right now to a low, okay, but AF will be 16x. We're going to start like that, and then we're going to increase our presets, visual presets, but still going to use the 16K resolution. I decided to show you guys three different presets for those who's curious. Today I'm going to show you the replay of the demo file that I'm going to include in the video description, just in case. This is going to be the Team Liquid versus the SK Gaming, one of the grand final. Great game, and let's go ahead and play it. I'm going to use this as a benchmark towards testing Counter-Strike Go any GPU architectures. We're going to test it with the Titan RTX in about a week, with the two Titan RTXs in about a week or two, and SLI, and within the future PC systems and within the future GPU architectures, guys. I'm commenting in real time, guys, as we go. Alright, so we have that screen right there. I'm going to use the command on the console. Look how small the console is. CL underscore draw hood space 0. Press enter. The radar and everything is disappearing on us. That's good. Let's go ahead and reboot actually the game. And I just reboot the demo, and I'm going to start over the demo. And every time I'm going to switch the presets, I'm going to reboot the demo, so we can, if we need it, to do the split screen when we're going to test against the Titan RTX, guys. And I'm going to create a beautiful video, Titan RTX versus RTX 2080 Ti, the kings of the Turing GPU architecture. It's going to be a beautiful video, single video cards versus SLI, split screen, coming very soon to iPlay4k.com YouTube channel. Go ahead and check it out, guys, and don't forget to smash the like button while watching this video, because a lot of time, money, energy was invested, guys. I'm losing my voice. I'm apologizing. My voice is a little bit squeaking because I recorded a lot of videos for you available. I recorded a lot of old school games at 16K resolution, and Turing GPU architecture is the first GPU architecture with enough of GPU cache, and even on the RTX 2080 Ti with enough of VRAM that is capable to run a lot of classic old school games at 16K resolution. Over the iPlay4k.com or iPlay16k.com, I'm going to, guys, include a lot of those old classic games at 16K resolution. You want to check it out because the experience is amazing. Even when you're playing 16K resolution rendered in real time, as I'm doing today, and you downscaling it to 8K resolution, it's still experience on another level. It's the experience, the visuals are much better than you playing 8K resolution and downscaling to 8K resolution, like native to native. You definitely can see 16K resolution rendered but downscaled to 8K resolution versus the 8K to 8K. This guy's obvious, and you can see it by the pixel density. The pixels looking much sharper, details much amazing than 8K to 8K. As again, this video is not the pixel comparison. Even if I'm going to upload this video in 8K resolution on YouTube, any adult knows that 4K resolution versus 8K resolution or 8K resolution versus 16K resolution, there is a much difference. Anybody knows that. And this video is not about the gameplay as well. This video is a computer science video where we're going to talk a lot about the Turing GPU architecture, especially when it comes to RTX 2080 Ti video card or RTX 2080 Ti 2 video cards in SLI. As again, to complete your full knowledge about the RTX 2080 Ti 2 video cards in SLI, in the end of this video I'm going to attach that video for you to study, as well as I'm going to attach the 16K resolution on the Titan RTX and 16K resolution CSGO on 2 Titan RTXs and 4-way Titan X Maxwell GPU architecture in world's first 10K resolution in CSGO back in May of 2016. I recorded the world's first 10K resolution of CSGO in May 2016, and I'm going to attach that video as well for you to study. Unfortunately, 4 Titan X Maxwell GPU architecture didn't scale well at 10K resolution, so we were like 70-80% on GPU scaling. But right now it's scaling pretty well, 99%, as you can see under the right top. The display information system is updated every second and self-explanatory, guys. I'm not putting those numbers running on the screen like all those copycats. Everything what I'm putting at the right top completely makes sense, understandable, as you can see, and this is exactly what we need to know. We don't need to know any other numbers, those funky numbers. It's just nonsense, okay? So the video card fan rotation, it's a dual design EVGA RTX 2080 Ti XC Ultra video cards, rotating at 100%. Okay, it's not so noisy, but it's kind of noisy. Keep that in mind. But it's much less noise than single Titan X Maxwell GPU architecture, guys. About 2 times less noise. I really like this RTX 2080 Ti video card. However, if you're planning to run 2 RTX 2080 Ti, guys, video cards in SLI, just make sure that the first video card that closest to the CPU is water cooled, and just go ahead and buy the cheapest possible version, a hybrid water cooler, RTX 2080 Ti. The best one will be by Gigabyte, Waterforce, amazing RTX 2080 Ti, guys, or GTX 1080 Ti. I enjoy both of them. I advise you to do so. Or grab yourself something by EVGA hybrid water cooled RTX 2080 Ti. The secondary video card could be an air, but the first one should be water cooled. Otherwise, you're going to thermal throttle your GPUs in SLI setup while running 2 video cards, RTX 2080 Ti, or any video cards in SLI, and you're not going to receive a full performance. However, 2 RTX 2080 Ti, it's scaling amazing in this game. It's just amazing, guys, demonstrating you almost 2 times performance. Okay, but as again, for you to study, go ahead and click that video in the end of this video, or I'm going to put that 2 RTX 2080 Ti and CSGO 16K resolution video in the video description for you to study for yourself and decide for yourself. Alright guys, so that's pretty much guys enough. Above 60 FPS, delay in milliseconds was way below 20 milliseconds average. It was completely stuttering free experience, completely lag free experience. You're going to enjoy it as I played at low. But let's go ahead and switch the preset. Instead of low, we're going to go ahead and switch to medium. Guys, keep your eye at the VRAM usage, which was 10,274 right now, but when I was running it, it was actually below 8,000 megabytes. And the system RAM usage is 13,000 megabytes, guys. Very high system RAM usage. I'm pretty sure when I was running it and it was showing below 8,000 megabytes on a VRAM, we were overloading the VRAM, and NVIDIA driver was removing some data, and instead of storing in the VRAM of the frame buffer, it was storing the data in the system RAM, which created 13,000 megabytes, and total my system RAM today is 32,000 megabytes or 32 gigabytes. Anyways, let's go ahead and switch it to medium, and let's go ahead and try the medium. I'm going to reboot the demo, and we're going to try the medium now, the medium settings. Let's go ahead and see how much FPS we're going to drop. Guys, as again, I'm recording this video today with the ShadowPlay, and it's recording in real time on the same computer, so I'm losing about 3 FPS performance. So to get the FPS without the ShadowPlay recording in real time, go ahead and add 3 FPS to the FPS counter. Okay, at the 16K resolution, it takes some time on us to apply the new presets, but should be no problem. I didn't have any problems with the 2 RTX 2080 Ti as well as single RTX 2080 Ti. Here we go. Everything maxed out, guys. Of course, no anti-aliasing at 16K resolution. We don't need that. So let's go ahead and reboot demo. I'm just going to go ahead and reboot demo real quick. And just start it over so you can compare exactly FPS. It takes some time, as you can see in the game menu. So okay, I believe that we refresh our VRAM. Look at that system RAM immediately went to 14,000 megabytes. Guys, I'm pretty sure even if it's showing the VRAM is below 7,000 megabytes, I'm pretty sure that we overloading our VRAM. But thanks God the game is not crashing, and that thanks go to NVIDIA driver that capable to manage without the DirectX surface crash or RAM overload, not enough air within the DirectX 9 API under the Windows 10 Pro. It's just amazing, guys. But it's storing some data into the system RAM, and it's obvious. Pretty much when I'm running any games, anything, guys, within my clear Windows 10 Pro operating system, my VRAM usage, my system RAM usage should be the RAM usage, actual system RAM usage. Should be below 11,000 megabytes. When it's above 11,000 megabytes, I can clearly state it, guys, that we are overloading our VRAM, and we pretty much getting that VRAM data into the system RAM. Okay, but it's not going to be very important data. It's just some of the cache we're storing into the system RAM, so we're not losing in particular game a lot of performance in CSGO at 16K resolution, because we're not calling that data a lot, calling it back. But we're kind of losing, I believe, about 3 to 5 milliseconds delay, time frame delay, as you can see in that milliseconds. So if we're going to have about 24 gigabyte of VRAM as Titan RTX, I'm pretty sure my delay will be 10-12 milliseconds, and we're losing that. We're increasing that latency delay in milliseconds, and it should be as small as possible to get this as silky smooth experience as possible. So we're increasing that milliseconds delay due to that the system RAM is only 2133 megahertz of the clock speed, guys, and as much as my overclock today on my VRAM, because my VRAM today on the RTX 2080 Ti, it comes from manufacturer 14,000 megahertz, and I overclock it with additional 2,000 megahertz, so it's not 14,000 megahertz, it's a 16,000 megahertz of GDDR6, 11,260 megabyte of the VRAM. Okay, so the VRAM is not enough, and or the NVIDIA driver decides it's not enough. It maybe could be enough. We will find out when I'm going to do the same test with the Titan RTX. But NVIDIA driver decides, approach in advance, okay, look like it could overload the VRAM, so I'm going to go ahead and store some data into the system RAM. I believe this is how software developers, when they coded the NVIDIA driver, kind of was using this kind of techniques and approaches, as I would use it as a software developer. So it's not crashing the game, it's kind of avoiding to crash the game, but giving you a little bit slower performance. So hopefully this makes sense. But in Counter-Strike Go, NVIDIA driver managing pretty well the offload from the VRAM to system RAM, so it's not reflecting by a lot in milliseconds delay, or not reflecting by a lot in our FPS. Keep that in mind if this makes sense. Okay, but as again, all of this information, it's nice to compare with the Titan RTX with the 24,000 megabytes of the VRAM. So we most definitely not going to overload our VRAM at anything. And I'm pretty sure with the Titan RTX, my system RAM usage with the similar conditions and presets and resolution on a similar system will be below 12,000 and even below 11,000 megabytes. But we're going to find out, and if this is going to be the case, that means that we most definitely were offloading some data from the VRAM into the system RAM. Okay, and I'm pretty sure that VRAM usage within the Titan RTX will be around 12,000, maybe even 14,000 megabytes under the VRAM usage. Okay, guys. Hopefully that makes sense. 99% GPU load, amazing GPU scalability. As you can see, CPU, we're not even 50% on my 6-core 6-thread CPU usage. So this is a clear signaling to us, guys, that future PC gaming will be more than enough within the 16-core CPUs, and I believe it will be the scenario all the way to 2024, the year when PC gaming and console gaming will die. It will be officially 2024. This is going to be a prediction by iPlay 4K, aka iPlay 16K. The first guy showed you on a YouTube 16K resolution gameplays rendered in real time. I was the first one in May 2016 with Half-Life 2 video on 4 Titan X Maxwell GPU architecture, and I'm the first one who showed you Counter-Strike Go at 16K resolution and any other old school games such as Battlefield, Bad Company 2. I also did at 16K resolution. I'm going to include a lot of cool videos, guys, in the end of this video for you to watch. Go ahead and check it out. It's going to be a great information. But anyways, we just saw the performance. Pretty much we were staying, guys, in around 60 FPS average, so it was comfortable, no stuttering as well. Delay was staying on average below 20 milliseconds, so it was under the medium. Let's go ahead and switch the resolution, and I'm going to reboot the demos again. Not the resolution, but preset. I'm going to use now the maximum possible preset, but anti-aliasing will be off, guys, because we don't have enough VRAM to run it with anti-aliasing off. I mean, if I'm going to increase any anti-aliasing, it's going to eat up everything what we have, and the game probably will crash. So we will try the anti-aliasing just in case with 16K resolution when I'm going to try it under the Titan RTX or 2 Titan RTXs in SLI in about a week or two. The video is coming for you, so stay tuned for it. So it's again very high, guys. Let's go ahead and have a look. So this is maximum high, very high, maximum possible visuals available for us over here. Hopefully it will update it real quick. Within this resolution, it takes about 10-15 seconds to update the settings. This is, guys, at the right top. This is the maximum possible font that they can run for the display information system under the 16K resolution. It doesn't go above this size in MSI Afterburner in 2019. Hopefully developers will fix that. I'm hoping for that, but they could be not, you know. And this is as big as font size as I can go. So please watch this video on the desktop or on a huge screen. And I also will try to upload this video in 16K resolution for you to watch. Okay, so let's go ahead and start this game over again, and this is going to be the last test. We're pretty sure we're going to see a lot of system RAM usage already, 13,810 megabytes, and they also increase on the VRAM usage as well. but the driver is managing pretty well in this game, in particular game Counter-Strike Go, pretty well 16K resolution, offloading the data from the VRAM into the system RAM. But it's not going to be that well at other games at 16K resolution. You obviously going to see when the driver is unloading some data from the VRAM to system RAM, and when you're going to see when that system RAM will be increased to 16,000 megabytes, even 18,000 megabytes. Sometimes you will receive your delay in milliseconds like 70, 80, 300, or even sometimes 900 milliseconds, and this is a clear signal that we are offloading a lot of data from the VRAM into the system RAM, and it's the data that called back a lot, and this is what creating that milliseconds delay, because as again system RAM is not as fast as the VRAM, because VRAM is operating at 16,000 megahertz in our case today, 2,000 megahertz additional overclock, and the DDR4 system RAM is operating at 2133 megahertz, guys, but CL13 timing. Guys, when it comes to DDR4 technology, if you're playing games 4K resolution and above, there is no reason for you to buy DDR4 technology system RAM at very high capacity and waste your money. Pretty much you're going to waste your money for nothing, guys. If you will play at 8K resolution, maximum you will receive 2 FPS average. Maximum if you will play when you're comparing 2133 megahertz versus 4000 megahertz, guys. CL13 to CL15, almost the same timing. 2 FPS maximum, but you will invest $500 more in the difference. For 2 FPS doesn't make no sense. Invest that money in a better CPU cooler, get yourself like hybrid Corsair H150i Pro as I'm running today with the liquid metal thermal paste, which is the best thermal paste, and Thermal Grizzly brand liquid metal thermal paste, the best one. And cool down your CPU, overclock your CPU, and you're gonna gain much higher performance per buck. Okay, or invest another $500 and invest towards the secondary video card and run 2 video cards in SLI. You're going to be Gucci, guys. Okay, this is my advice to you when it comes to DDR4 technology system RAM. Get yourself as cheap as possible, but please make sure that you're grabbing yourself 32 gigabytes if you playing games and if you do something else as well, because 32 gigabytes for the future will be good to go, especially if you're not looking to update your system every year. Just grab yourself 32 gigs, you're going to be good to go, guys. Look at that. With the heavy particles, FPS sometimes even jumping to 25 FPS like for a couple seconds I just saw, but as again, just because I'm recording with the ShadowPlay technology by NVIDIA in real time. Without the recording, please add 3 FPS, guys. And that heavy particles with a lot of small grenades, they going to decrease your FPS dramatically, no matter what kind of resolution you're running. And it's pretty amazing performance, actually, guys. As again, just guys, don't forget to smash that like button. A lot of time, money, energy was invested. This is the world's second, indeed, 16K resolution rendered in real time, or 133 megapixels rendered in real time, downscale in 8K resolution. But it doesn't matter if it's downscale or not, it's still rendered in 16K resolution. And to be rendered at 16K resolution, it requires at least this kind of performance, and at least during GPU architecture, because the previous GPU architectures, guys, couldn't run Counter-Strike Go or CSGO at 16K resolution. I tried with the 4 Titan X Maxwell GPU architecture. It was crashing above 10K resolution. Pascal GPU architecture was allowing us to run 12K resolution. Okay, as I tried it with the Titan XPs. But 4 Titan X Maxwell GPU architecture couldn't handle 12K resolution, guys. And Turing GPU architecture that is equipped with our RTX 2080 Ti as GPU in our video card today is allow us to run 16K resolution, and I believe it's due to higher GPU cache on our Turing GPU architecture. So the RTX 2080 Ti is the first video card, guys, that allow us to play Counter-Strike Go game on the planet Earth at 16K resolution, and even you can play it within the single RTX 2080 Ti. But with the two RTX 2080 Ti, guys, on SLI, the experience is mind-blowing. It's running so fast, and I'm going to include that video in the end of this video for you to study. Guys, my voice is kind of squeaky. I recorded a lot of old school classic games for you in 16K resolution. Go ahead and check them out. As again, just visit iplay4k.com YouTube channel. It's going to be a playlist, 16K resolution. Check those videos. It's going to be amazing performance. I'm going to record. I was the world's first YouTuber that recorded a lot of games at 16K resolution rendered in real time. When I'm saying rendered in real time, indeed it's rendering in real time. And it doesn't matter, guys, if it downscale to 8K resolution or not. It doesn't matter what kind of resolution I'm downscaling it right now. It's all about the performance. It means that when the 16K resolution or 4 8K resolution screens will be connected to this setup, it will show us the same FPS plus minus 2 FPS, and this is incredible. So this is the computer science video. This is the video is about the performance. It's not about the pixel comparison, not about all this nonsense the naysayers are saying, not even about the gameplay. I'm just using the grand final demo just as our benchmark, so we can use the same demo towards anything now, the similar same demo, so we can also do the split screens and stuff like that and do all kind of great videos. Look at that, at high, just amazing. The details and everything is just on another level, and we still, guys, running at 60 FPS average almost. That's incredible averages right there. Sometimes it's dropping to 35, but this is a maximum visual preset, but anti-aliasing is off. Yeah, I'm pretty sure this preset on the Titan RTX we're going to be in around maybe 13,000 megabytes under the VRAM usage instead of 8,310 megabytes as I'm using right now, because it's kind of fake data. The system driver, NVIDIA driver is faking it for us. So again, it's offloading real quick the data in the system RAM, and I'm pretty sure that my system RAM under the Titan RTX with a similar scenario will show us around 10,000, maybe maximum 11,000 megabytes of the system RAM usage, but it's going to show us a lot of VRAM usage, because the driver is not going to be limited, and it's not going to freak out, and it's not going to offload the data from the VRAM into the system RAM. Guys, hopefully everything makes sense. As you can see, as higher resolution I go, the less CPU I'm using. So you can see the 6 core will be great. But I'm eyeing, guys, one of the CPUs with the Ryzen 16 cores, 32 threads. It's going to be the best, even if I'm going to be lowered by 2-3 FPS that I'm having right now, which AMD claiming it's going to be as fast as 5,000 megahertz. So I'm pretty much with that Ryzen as fast as 5,000 megahertz Core i9-9900K. We're probably going to be with that Ryzen, I believe 3950X. I'm going to 16 core, 32 threads. Probably going to be 2 FPS lower that I'm having right now, but that CPU is going to be amazing, especially for the video encoding and stuff like that, and I could run a lot of great stuff, and this is what I'm eyeing for the future, and this is probably going to be my future CPU. Otherwise, I'm not advising you to switch to a newer 3000 series Ryzen CPUs, especially if you're low on cash, and if the gaming, YouTube, or video, slightly light video encoding, or even 3D modeling and 3D animation is your thing, and you're doing kind of lightly on daily basis without like 3 videos encoded in the same time, then you're going to be good to go, even with the i5 9600K that I'm trying to emulate during this video, because 6 core 6 threads is pretty much i5 9600K at the 5.2 gigahertz, and most of the i5 9600K within the Corsair H150i Pro water cooler system will give you about the same FPS, guys. Okay, and that CPU in 2020 you can buy for around 160 bucks, and I advise you to go with that instead of Ryzen, a similar 6 core 6 thread CPU, guys, because you most definitely going to show at least 3 FPS higher than Ryzen 3000 series CPU. So Ryzen is not the king and it's not the leader. Ryzen is just catched up with the almost 2 years of the Intel Core i9 generation CPUs. This is how I'm looking at it, not as a marketing copycat, but as a hardware enthusiast, the real hardware enthusiast, guys, that touch a lot of hardware and stuff like that, as well as I'm a 3D artist, graphic designer, software developer, and hardware engineer, because since 2014 till 2017 I touched over 5,000 systems. Most of them was top of the end, guys, and most of them was servers. And let me tell you, in data centers, Intel servers dominating the industry. So those copycats marketers, they're saying the AMD is dominating the server market. They're not, guys. I saw about 50 data centers in the United States, and I never saw a client with the AMD system. Most of them was Dell, Intel CPU architectures, guys. Servers, keep that in mind, 99%. So AMD company is dead, guys. They will catch up, but they will go bankruptcy in 2014. But in 2014, the PC gaming and console gaming will be dead. This is part of my story. And Intel will go to enterprise. They will survive at the enterprise level. AMD will be dead, and NVIDIA will also go to enterprise and AI card development systems. Okay, this is my solution, and I'm going to create a video for you. I'm going to show you where this where the gaming will go in the future. I'm pretty sure the copycats will try to copy me that watching these videos, but guys, you want to watch my video, for my original video as a PC hardware enthusiast, that for real with the all open heart was for about 20 years as PC hardware enthusiast and overclocker. I'm not like those copycats that just open their YouTube channel and they have a lot of subscribers and likes. And why they having that? Because pretty much they saying everything what you want them to say, and I'm not saying everything what you want me to say. I'm telling you exactly what it is in real life, even if it hurts, if the truth, it hurts a little bit, but I'm saying the way it is, guys. Okay, so that's why a lot of people hates me, and sometimes people creating groups and they hate my YouTube channel, hitting the dislikes. But don't worry about that, guys. Hit that, smash that like button, subscribe, support me, share it with your friends. A lot of cool content will be over the iPlay 4K YouTube channel. Don't forget to check it out. And right now, guys, I'm putting some great videos for you to check out. Check it out, and I guess I will see you in the next time, guys. Let me real quick go ahead and show you that this is the last test. Was everything maxed out, but the anti-aliasing was off. I don't want to enable the anti-aliasing because, as you can see in the menu, we are over 10,000 megabytes, and I believe this is the real data right now. I believe this the NVIDIA driver somehow not saving us when we are in the menu. So maybe this is 11,000 megabytes, almost our VRAM usage with this presets. I'm pretty sure, guys. The next video that I'm going to record will be Half-Life 2, 16K resolution, Alien vs Predator 2010, 16K resolution. Don't forget to check it out, and Titan RTXs, guys, single and Titan RTXs, 2 of them, and SLI videos are coming out. I think I pretty much going to wrap up with RTX 2080 Ti. I covered a lot of data in this video card, guys, over the iPlay 4K, aka iPlay 16K YouTube channel. And now it's time to cover the king, and in terms of the ultra high HD high definition resolutions, which Titan RTX, the 24 gigabyte of VRAM, will be need, guys, and it will dominate RTX 2080 Ti almost at anything. I believe that we will be able to run Need for Speed 2015 at maybe 12K resolution or even 16K resolution with 2 RTX 2080 Ti above 30 FPS. But we're going to find out, guys. Stick around, smash that like button, check out the videos, and I will see you till the next time.